I changed from batch to continuous distillation in the hope that it would produce a better vodka at lower cost. It did, but the advantages were marginal and qualified. I'll describe the pros and cons I have found to inform you the judgment of whether or not you want to try it. Continuous stills are ubiquitous in commercial distilling operations. The reasons are economic and don't translate that well to home distilling. It's a continuously operating automated system. It takes up a lot less space than pot stills, has high utilisation of equipment, low labour costs, high yield and low energy use. It's used for making a wide range of spirits, including whiskies, brandies and rums, but it tends to be used for the cheaper versions of them. Those spirits extract flavour from wash, and the columns used in continuous distillation have multiple draw points, with less volatile flavour chemicals appearing lower down the column and more volatile higher up, with alcohol and heads chemicals at the top. The distiller then mixes products from the various draw points to achieve their desired flavour. I haven't done that, and were I making whisky or brandy, I would probably stick with a pot still and use cuts to select flavours, as that's the traditional method and the method associated with the highest quality commercial products. Neutral spirit, though, is a different animal. It is a tasteless spirit distilled close to the azeotropic point. It isn't a drink, being too strong at 96+% ABV or alcohol by volume. It's either cut down with water to make vodka, or used to make other drinks that are finished by adding flavours after distillation, such as gin, various liqueurs and absinthe. For home distillers making neutral spirit, continuous distillation does have some advantages. One of these is that it's easier to control the column. Wash is pumped in at a constant ABV, so you don't have to compensate for declining alcohol content of a batch of wash with repeated adjustments to heater power. Initially, I had hoped it would be cheaper and take up less space to set up a continuous still than a batch still, as it does not use a large boiler, which is an expensive item. But adding together all the necessary electronics and pumps, that wasn't true. I ended up spending about 20% more on components for the continuous still than I did for the pot still using the same rectifying column. I also hoped that it would produce a better neutral spirit. It does produce better neutral spirit than most home stills, but when compared with my pot still system, which was designed with the same object in mind, that advantage is more questionable. The best spirit I got with the pot still was basically indistinguishable from the best I got with the continuous still, but the continuous still is more consistent. It gives fine product throughout a run, whereas with a pot still run it varies, particularly towards the end of the run, if the still goes out of tune, which it can do as power adjustments gets larger and more frequent towards the end. Continuous distillation does give you 5 to 10% more yield for the same wash. With batch distillation, whatever column cooling system you're using, there's likely to be a limit to how much heat it can remove while maintaining a long enough isothermal section for azeotropic distillation. This limits the power that you can deliver to the boiler. In order to maintain a constant alcohol flow, you have to increase the power progressively as the alcohol content of the boiler falls, and more of the heat is used to generate steam. That means that you can't get down to 0% ABV in the boiler. In my experience, you usually come to the end of a run at around 1% or a bit less, giving a yield of between 90 and 95% of the alcohol in the wash. On the other hand, with continuous distillation, alcohol extraction depends not on boiler power, but on the performance of the stripping column. With my stripping column, which is cheap and easy to make, waste alcohol content is more like 0.1%, giving a 5 to 10% increase in alcohol extraction. Related to this is another advantage of column distillation. It's more energy efficient. The increased energy required to vaporize wash as the alcohol concentration of a batch declines does not occur, so the power requirement is the same throughout the run for continuous distillation as it is at the beginning of a run for batch distillation. Further, with continuous distillation, it's easy to recover some of the heat lost in hot bottoms to heat the incoming wash. These two effects mean that continuous distillation requires approximately half of the energy of batch distillation for the same wash. There are also disadvantages to continuous distillation. The still has to be run continuously because it takes a long time for the temperature to stabilise, and my narrow column takes many days to distill 5 litres of neutral spirit. This is not true of most home stills, but actually it is true of my pot still. Because of the continuous operation, the still has to be designed to be safe when left unattended, which means it has to fail safe, adding a few complications. It also means that you won't be welcomed into the home distilling community, as running stills unattended is taboo for them. Another disadvantage is that it is complicated to set up, requiring computerised electronics to manage stepper motor driven pumps, temperature sensors, atmospheric pressure sensors, and possibly digital parrots as well. So if you are thinking of building a continuous still, I would suggest considering these 3 points. Firstly, do you want neutral spirit? Because that's the only thing that my continuous still makes. If you're not sure, then I suggest making a pot still using the same column and then building a continuous still if the product is to your liking. Second, how much neutral spirit do you want to make? The more you want, the stronger the argument for a continuous still, because of the economic and yield advantages. Using a 150 litre fermenter and sugar wash, it takes me about 2 weeks to ferment a batch of wash, and it also takes about 2 weeks to distill it, so I can keep the still fed continuously for a neutral spirit production rate of around 7 litres per week. Thirdly, setup costs and space saving are not good reasons for continuous distillation. The process I use relies on having a pot still as well, because I strip distill the wash to about 35% ABV and then distill the strip. You can distill directly from wash, but if it's not carefully filtered, its solid content leads to occasional blockages. A greater advantage of stripping is that carbon filtration and ozone treatment are more effective at lower alcohol concentrations than neutral spirits 95+%. I ferment a 150 litre batch of sugar wash, then strip distill it in 3 batches with a 50 litre pot still, which gives me around 50 litres of strip. I put this in a barrel with a 1 kilogram mesh bag of activated charcoal, as is sold for fish tanks. It takes 3 or 4 days to purify the strip, and I may or may not bubble ozone through it during this time. I then distill the strip in the continuous still, and that gives me the best product I've had so far. You can see that the practical advantages of continuous over batch distillation for the home distiller are pretty marginal and limited to making drinks that are based on neutral spirit. And I think the most compelling argument for doing it is that you're attracted by the technical challenge. And it does teach you a lot about electronics, process control, and the chemical engineering of distillation.